Now let's look into the one of the very important test which comes under the statistical inference is A/B testing. This is just an introduction to A/B testing in statistical analysis. So an A/B test is an experiment with two groups to establish which of two treatments, products, procedures are the like is superior. Often one of the two treatments is a standard is the standard existing treatment. Okay, so often one of the two treatments is the standard existing treatment or no treatment. If a standard treatment is used, it is called the control. It's called the control. The standard treatment is used, it's called the control. So a typical hypothesis is that a new treatment is better than the control. That's what the A/B testing typical hypothesis. A new treatment is better than the control. So now let's so in this context, what is a treatment? Treatment is something to which a subject is exposed. That something could be a drug, a price, or a web headline. So these are known as treatments, and we have a treatment group. A group of subjects exposed to a specific treatment are known as treatment groups. So then a control group, a group of subjects exposed to no treatment, or we can call them as the standard treatment, as we have discussed earlier. The basically often one of the two treatments is the standard existing treatment, or we call it as a no treatment also, because so we won't be specifically treating that, so that the reason the standard treatment is also known as no treatment. If a standard or no treatment is used, we call this as a control group, and the subjects, a group of subjects which are exposed to the standard treatment are called a control group, and the group of subjects which are exposed to a specific treatment are called a treatment group. And we have randomization. So the process of randomly assigning subjects to treatments. The process of randomly assigning subjects to treatments is known as the randomization. So now what is subject altogether? So what is subject? Subject, the items. It could be web visitors, it could be patients. When these are exposed to treatments, then we call them as a subjects. So subjects, the items, it could be they could be web visitors or patients, or it could be anything else which are exposed to treatments are known as subjects. Then we have test statistic. The metric used to measure the effect of the treatment is known as the test statistic. It could be number of visitors, it could be number of patients. So these are called test statistic. If it is mean of the number of visitors of a sample, this is a test statistic. So just let me repeat it one more time. Treatment, uh, something, a drug, a price, or web headline to which a subject is exposed. Then what is subject? Subject, the items. It could be web visitor or patients that are exposed to treatments. That's it. The treatment and then subject. Then treatment group, a group of subjects exposed to a specific treatment, and then a control group, control group, control group, a group of subjects exposed to no or standard treatment. A standard treatment is used, no, if one of the two treatments is the standard existing treatment or no treatment. So that's what is called a standard treatment. And randomization, the process of randomly assigning subjects to treatments, and finally the test statistic, the metric used to measure the effect of the treatment. So A/B tests are common in web design and marketing since results are so readily measured. Some examples of A/B testing include, let me write it down. This is one of the example. Testing to websites or to web headlines to determine which produces more clicks. Welcome to our website with this design or with this design, with this different color or with this color, which creates which produces more clicks. So this is one example. So like that, you can have a huge amount more number of examples. Let me write down here. A/B testing. So one example is testing to soil treatments to determine which produces better seed germination. Sorry, which produces better germination. So next example, second example, testing to therapies to determine which suppresses cancer more effectively. Then third one, testing to prices to determine which yields more net profit. And next example we have seen before, that's testing to web designs or headlines to determine which produces more clicks. Then one more example, testing to web ads to determine which generates more conversions. So these are some of the example, and one example you can see from here only. So a proper A/B test has subjects that can be assigned to one treatment or another. The subject might be a person, a plant seed, a web visitor. So the key is that, let me write it down that also so that it would be very clear for you. So subjects, who are the subjects? Subjects, the one who's being subjected to some kind of treatment. Simple definition, my own definition. So subject could be a person or a plant seed if our treatment is soil, or a web visitor. Okay. So the key is that the subject is exposed to the treatment. Ideally, subjects are randomized. Randomized are nothing but they assigned randomly to treatments. In this way, you know that any difference between the treatment groups is due to one of the two things, either the effect of the different treatments or lack of a draw in which subjects are assigned to which treatments. That's a random assignment may have resulted in the naturally better performing analysis being concentrated in A or B. So you also need to pay attention to the test statistic or metric we use to compare groups. So test statistic. So example, perhaps the most common metric in data science is a binary variable. In data science is binary variable. So click or no click. Example, click or no click, buy or don't buy, then fraud or no fraud, and so on. So those results would be summed up in a 2 by 2 table. So if you see the let's make a 2 by 2 table for e-commerce experiment results. Okay, e-commerce experiment results. So outcome, so price A and then price B. So conversion 200, then 182, then no conversion 23,539. This is just a count, and 22,406. So in this example, if you see, this is an actual price test of for the. So if you see this metric, an e-commerce experiment result, if the metric is a continuous variable such as purchase amount, profit, or account, which is days in a hospital, days in a hospital, or maybe pages visited, the result might be displayed differently. If one were interested not in conversion but in revenue per page, then the results would be something different. So if in spite of working on no revenue per, in spite of working on conversion, if you work on a revenue per page view, the results of the price test might look something different. So now let's write down revenue per page view with the price A. Obviously the test statistic mean, that's 3.87. This is one, and SD standard deviation is equals to 51.10, and same applies revenue per page view for different second one with price B, mean is equal to 4.11 and SD is equals to 62.98. So that's what revenue with price A and then price B. So this is how even we use a test statistic with this one. So SD refers to the standard deviation of the values within each group. Just because just let me get back to the slide. Okay, so the next question that comes into our mind, why have a control group? Why have a control group? Why not skip the control group and just run an experiment applying the treatment of interest to only one group and compare the outcome to prior experience? It seems sense, it makes some sense, it makes some sense, right? So why not skip the control group and just run an experiment applying the treatment of interest to only one group and compare the outcome to prior experience? So without a control group, there is no assurance that all other things are equal and that any difference is really due to the treatment or to chance. When you have a control group, it's subject to the same conditions except for the treatment of interest as the treatment group. If you simply make a comparison to baseline, or prior experience, other factors besides the treatment, it might differ. So, so A/B testing in data science is typically used in a web context. Treatments might be the design of a web page, the price of a product, the wording of a headline, or some other item. Some thought is required to preserve the principles of randomization. So typically, the subject in the experiment is the web visitor, and the outcomes we are interested in measuring are clicks. So clicks, purchases, visit duration, number of pages visited, whether a particular page is visited, and the like. So in a standard A/B experiment, you need to decide on one metric ahead of time. So multiple behavior metrics might be collected and be of interest. But if the experiment is expected to lead to a decision between treatment A and treatment B, a single metric or test statistic needs to be established beforehand. So selecting a test statistic after the experiment is conducted opens the door to researcher bias. So after looking into the A/B testing, no, and very important concepts of A/B testing, one more new question pops into our brains. That is, why just A/B? Why not C, D? Okay, why just A, B? Why not A, B, C, D, E, F, G? So A/B tests are popular in the marketing and e-commerce worlds, but are far from only type of statistical experiment. Additional treatments can be included. Subjects might have repeated measurements taken. So pharmaceutical trials were subjects where subjects are scarce, expensive, and acquired over time, or sometimes designed with multiple opportunities to stop the experiment and reach a conclusion. So, traditional statistical experimental designs focus on answering a statistic question about the efficacy of specified treatments. Data science are less interested in the question, is the difference between price A and the price B statistically significant, than in the question, which out of multiple possible prices is best. So for this relatively new type of experimental design is used the multi-arm bandit. Okay, if you want to check out of multiple possible prices which is best, A/B testing. In spite of the A/B testing, the data scientists will use multi-arm bandit algorithm. Multi-arm bandit algorithm. We will be discussing about this. Not to worry, we'll be discussing about this question, this algorithm in this course, inferential statistics. So the multi-arm bandit algorithm.